no. Why to leave a royal city and go to a dump yard? Yeah.
No, sir.
Very good. Wonderful. Catch up when you are in Mysore. Give me a call.
Yes, sir.
Okay?
Yes, sir.
We should meet. Yeah. Okay.
Definitely,
Good.
sir. Definitely.
Good. Wonderful. Well, we are 3 minutes past 4 o'clock.
Yeah, we'll just wait for 2 minutes more, and then our president, if he join.
Yeah, I can see him there.
Dr. Jindal Saab. Dr. Prakash, yeah, when this Zoom was not in picture, but I remember in one of the AIFPA seminar at Chennai, you connected through via telephone.
That's
that
right.
time we were thinking, how come it is possible? You said no, it is possible, Prabodh. I will give the keynote address on telephone. Literally,
Namaskar to the chief guest.
Namaskar, Kaul Saab.
Namaskar.
So literally, I kept my phone to the mic,
My
and
best
that time it was
wishes
like
to Dr. Halde. He has made his commitment.
Yeah, no, sir, always.
And
So
our
I was
most proactive and dynamic president of the association, Dr. Jindal.
Jindal Saab
Thank
hai
you,
kya?
Kaul Saab,
Right?
for your kind words.
So despite my bad health, I have made it.
Yeah, that's the biggest point.
How is your health, Kaul Saab?
हाँ जी.
आपकी health कैसी है?
So shall we wait for a moment?
I think all the guests have come, all the speakers are there.
Yeah.
Let's initiate the program. Let people join in between, because we have a evening. We don't want people to be on Friday evening
No,
delayed.
as
It
I
is already
shared
5
with
minutes
you,
delayed.
the program in the afternoon was only to let some of the speakers, panelists from US to join. So
Yeah.
4 p.m. here would have been 6:30 in Oklahoma and other places in US.
I
So
agree,
it was on their request. Huh? I'm sorry
No
for
problem.
the inconvenience, if any, to others. See, Dr. Dreesker from USA has already joined. Right? I'm pleased to see Dr. Dreesker. Thank you
Good
so
morning,
much.
sir.
Thank you so much for joining the webinar.
Not at all. Would not have missed it.
Thank you so much. And give my regards to Dr. Patricia as well.
I will do so.
Okay. Dr. Jindal, can we continue now?
Please carry on.
Please. Yes, Mr. Dr. Alde.
Yes, sir. All said, go. So, should I start, or you want to
Yeah,
do the
please
welcome and
start.
then? Okay. Good evening and good morning to US and the other part of the world, those who have joined this wonderful webinar come seminar. And first would like to thanks to all our dignitaries, our chief guest Padma Shri V. Prakash sir, our esteemed speakers, Dr. Vatke Saab, Dr. RBN Prasad, and Dr. Kaul Saab, and our beloved president of AIFPA, Dr. Jindal Saab, for honoring this session. Friends, as you are aware, oil and fat industry, as whatever is said, that 70% of the oil is getting imported to India. And it is very important to increase our advancement in oil technology and particularly in the science of oil and fats. So this webinar, which is named after technological forecast perspective for future sustenance of Indian oil industry. And we got a fantastic 3 speakers and the chief guest, Dr. V. Prakash sir. So now I request our beloved president sir, Jindal Saab, to give the opening remarks, and then we'll proceed for the webinar. Over to Dr. Jindal, sir.
Dear friends, thank you very much, Dr. Halde. It's a great pleasure for me to welcome all our esteemed guests. We have Dr. V. Prakash, the luminary in food technology, and I think now more an industry member than just a technologist.
Always,
Distinguished
always.
CSIR fellow. Okay, he is always thinking of the industry, how industry can adapt newer technologies and become more and more competent, strengthen itself, and take on the globe. And I am grateful to Dr. Bresker for joining and accepting Kalsab's invitation. And Dr. RBN Prasad, our learned speaker, Dr. Watke, and Mr. P.L. Kaul. Friends, it is a very important topic that has been selected for this webinar. Normally, when we talk of food, so many other segments, come up first. We have dairy to speak about, fruits and vegetables. We have tea and grains, a large family of components. However, I truthfully feel that oils have a place in the entire food sector of its own. Just to give you a simile, when we think of education, we think of language with which knowledge flows. Information is disseminated, emotions are conveyed, and values are shared. Language does it all for education. Imparting education will be almost impossible without a language. I would like to say that similarly, when we think of food, we think of oil as the vehicle for providing taste and aroma, enhancing the flavor of spices, blending ingredients, sterilizing the food at a high temperature as a property of the oil, adding nutrition to food, and improving the overall appeal and utility. Now, these are properties which normally do not come to the forefront in everybody's mind, at least in the consumer's mind. And therefore, when it is an age, when we have to make the consumer aware of what the real function of edible oils are and how to select, how to take it forward, a seminar like this would be very important to educate ourselves, the industry, share views within the scientists and technologists, and then see what lies next. I think today we would go to that further step. Think of technology, processing, machinery and equipment, packaging, product integrity, shelf life, nutrition, blending, and perhaps also touch upon a number of anomalies and challenges in this sector. As Dr. Halde just mentioned, we are a vast country. We have huge potential for crops of oil seeds. But yet, we import the major quantity of what we consume. this is not very encouraging. In fact, if given the liberty, I will say it is, shameful for India not to be able to do that after 7 decades of being independent. Similarly, there is a second issue, challenge on perception. Every nutritionist, dietitian, medical practitioner that you talk to give you the first impression that fat is bad, oil is bad, avoid oil. So we begin to look at oil from the reverse side of it, not from the positive side of it. The negatives come in play when we are not using the right oil. The properties are not fine. There are certain components like trans fats which we take in. And then also we are not talking about the functions which the oil does on food, how it combines the various properties of food, its nutraceutical components. So I think there is a need today that we put the whole thing in the right perspective. And what better could it be to have a group of leading technologists and scientists and industry persons together. So I will, with this note, request you all to put in your thoughts, views, give your suggestions, and maybe through this we will take on some recommendations for the government which can make this sector more easily acceptable and value added. There are other concerns which relate to taxation, which relate to exports, which relate to the properties of the food, which by using different oils. And I will not shy to say that today we have the burden of importing and using palm oil, which has been proven to be not the best. And second point, there are certain interest groups across the globe which want to denigrate the good Indian heritage oils, be it coconut, mustard, sesame, and a few others. And of course, the ghee, which is, above all. So I think this is the duty of the technologists today, not to just look at the machinery and the processing and the, packaging part of it, but also tell the world, the consumer, what is really the best to be consumed. So friends, please give your opinions and recommendations. Thank you very much. I welcome you all once again and wish that this webinar brings out good thought points. Thank you once again.
Thank you, Dr. Jindal. In this, you have given the important about the oil industry and what are the challenges which India has. So, friends and the participants, today, what actually we are doing today, there are 3 speakers, as I said, and these 3 speakers, like Dr. Jindal has said, all these are the distinguished in their respective area, and our chairperson and the president of this today's function, the chief guest of the today's function is above all, is the Padma Shri V. Prakash sir. As you said, in the food category, the fat carries maximum weightage of calories, which is 9 calories. So, Jindal Saab, today's speakers carries the maximum weightage in the respective area. So, the first speaker is Dr. Kaul Saab. After that, Dr. Vivek will be there, and then Dr. RBN Prasad sir. Let me take liberty of introducing all the three and our chief guest. Starting with our chief guest, sir. Viprakash sir, I am actually standing opposite to the heritage building of CFTRI. And when we come to CFTRI, we always remember Viprakash sir because from my college time, way back in 1994 time, we have kept seeing you, sir. And this CFTRI, the ex-director of CFTRI, Viprakash, everybody knows. He is a Padma Shri. But not only limited to the food technology, he has huge, humongous work in the area of nutraceutical. He's also president of International Union of Food Science and Technology. He's the vice president of International Union of Nutrition Science. He's the chairman of Indian region of European Hygiene Engineering Design Group. He's adjunct professor at Ramja University of Applied Science, Bengaluru, India. He is also distinguished scientist of CSIR India. He is Padma Shri. And he got various awards, including our own association, AIFPA award. And he has been the lifetime achieving awardee from many of the association. Then we have today's first speaker, Kaul Saab, and who is actually the whole organizing of this program is his brainchild. Dr. Kaul Saab is our ex-president of AIFPA, and from last 40 years, he's serving the country through his one company, which is the Marintel India Private Limited. He is the CMD of the company, and which is in the innovative project designing and implementation from last 40 years. In spite he is unwell. Yesterday he called me, he said that he is carrying the fever of 102, but in spite of his fever, he is committed, and today he is the speaker at our session. He has set up more than 51 projects in India and more than 82 engineering and food processing projects all across the globe from the grassroots. And he is expertise in food processing and agro-based industries, including the oils and fat. Dr. Kaul is a recipient of many prestigious awards, including Kalkar Memorial Award by AFPA, and he's been associated with various R&D initiatives. And at this age, he's very active in our AFPA community for the food engineering, food processing. After this, I'm so happy to introduce our other friend, my mentor and my colleague at Solvent Extraction Association, Dr. Vivek Vadke sir. Vivek Vadke sir is the BTech from IIT Kanpur, Kharagpur, way back in 1980. After that, he went to US, Canada for his MSc and PhD. And he is the alumni of very renowned food technology college of Waterloo, Canada, and he completed his PhD in 1983 and 1987. 83 he completed his MSc. After that, 87. Then he served the various companies for 20 years, and then he started his own consultancy services in expelled oil in refinery. If one person has to be named as a technical expertise, Dr. Vivek Vadke is one of the persons. And Dr. Jindal Saab, we are in process of actually introducing his book written by him, the oil and expelled oil technology for the industry, and very soon it will get published. We are in process of that. Dr. Vadke is a humble person, and he has given so many technology transfer to expelled people, small people, and which what you are talking about, Save India and Make in India. He is also technical convener of Solvent Extraction Association for the technical group of oil and fat. The third speaker, which we have found, is Dr. RBN Prasad. I'm so happy to introduce you, Dr. RBN Prasad. Today only we interacted on FSSI platform. RBN sir is ex-president of AFST, and during his time, we did so many initiatives. He's also the distinguished scientist of CSR, Indian Institute of Chemical Technology, and he retired as the head of the department of the Center for Lipid Research. Presently, though Dr. Prasad is the retired, but it is just a namesake. He is still working more than 12 hours a day, guiding many industries, working intensively with the DST, DSIR, various associations, and he is guiding more students. Let me tell you, RBN is equal to RBO in India. Rice bran oil, the first rice bran oil physically refined, has been invented by Dr. Arvind Prasad. He holds the patent, and actually earlier rice bran oil was not edible grade. The challenge of converting non-edible grade to edible grade, Dr. Arvind Prasad contribution is huge. And the color problem, the particularly deodorization problem, reduction of the trans fatty acids, Arvind Prasad sir has done a fantastic job. I know Dr. Arvind Prasad over last 20 odd years. And I'm so fortunate, Dr. Jindal Saab, all the three preliminary speakers, I know them from last 20, 25 years. Dr. V. Prakash sir, I know you when I was a student in 1990 as a student. So over now, close to 35, 37 years. And it is so delighted. All the participants, it is going to be the best program in your lifetime because all the great speakers in the oil industry are here. So I request now our chief guest, Dr. V. Prakash sir, just to say 2 or 3 words. Then you will be talking at the end of all the speakers for the concluding. But we require your motivating talk to all the speakers and participants. Over to Padma Shri V. Prakash sir.
Well, I will reserve my comments for the end. But however, dear Subodh, Kaul, Prabodh, RBN, and Wadke, members of AIFPA, nationally and also internationally, I guess, academia chiefs. And Prabodh is physically there in CFTRI to beam the knowledge of CFTRI to all of you. So it's kind of a mobile TV tower that he has on top of his head to do that. Industry captains, regulators, I see Rajkumar from FSSA has logged in, financiers, startups, consumers, edible oil sector, wonderful partners, and very, very seamlessly participating SMEs, indeed an important subject to deliberate. I am also really looking forward for some solution to make sure that today's deliberation and recommendations from AIFPA will solve this really a perennial problem of shortage of oil. So the fundamental responsibility is to produce a good report, very short report, but very powerful report from AIFPA to make more India edible oil in our daily diet. And I think that should be our motto. And just like our Honorable Prime Minister says, made in India, produce edible oil in India, is the mantra that we need to really do it. And we can do it because we have done it in milk, we have done it in vegetables and fruits, we have done it in eggs. Name it, we have done it. So it's only a question of deciding and moving forward. And I'm extremely happy that all the concerned people are today here. I'm also looking forward to the bright talks from all the three speakers and look forward to gain the knowledge. And I'll come back in the end again when I have to conclude the session. Thank you, wonderful Prabodh, and wish you a nice day in CFTRA. Bye-bye.
Thank you, Professor. Thank you. Now I request to give a theme lecture by Mr. P.L. Kaul. And after Dr. P.L. Kaul, we will be having Dr. Arvind Prasad sir. After that, Dr. Vivek Wadke. Over to Shri P.L. Kaul for the theme lecture. Sir, we have delayed by 7 minutes. So we request all the speakers to be on the time because V. Prakash sir is very, very particular about the time and we want to close the session by 6 p.m. Over to Kaul sir. All the questions will be taken at the end. So don't disturb the speaker and over to Kaul sir.
Sir, please unmute yourself. Sir, unmute yourself, sir, please. Sir, we are not able to hear you. Please unmute yourself. There is a mic at the bottom. You need to unmute, sir. No, sir, you're still on mute.
Please call is on his phone and then talk to him. He may be not able to.
Please unmute.
Is it okay now?
Yes,
Am I
sir.
audible?
Yes, sir.
Yes.
Okay. And now let me share the screen for my PowerPoint presentation. The host has disabled the participant screen sharing. Vikas?
You can share your PPT now, sir.
विकास जी जितने भी हमारे प्रेजेंटर है उनको आप को होस्ट बना दो तो they will able
Sure.
to share the screen. Thank
I've
you.
done that.
Thank you.
स्क्रीन में ये PowerPoint presentation शेयर कर लो ना ऑन विकास.
Sir, you want me to do it?
Yes, you do
I've
it.
given
I'm
you-
not able to do it from here.
Okay, okay. Just give me a moment. You need to cancel screen share first, sir. You need to cancel it so that I can.
Okay, I have done it. I have done
Okay.
it.
Right. Just one moment.
No, is there any
Yes.
problem?
You just give me a moment, please.
Yeah, until my PowerPoint presentation goes on, let me say good morning to Dr. Dreesker and good afternoon to all my friends here. Always gratified with the presence of Padma Shri Dr. Prakash, who has always been our mentor and counselor and guide for every problem, whatever we have and we come up with. Dr. Jindal also, a friend, president of the association, always proactive and dynamic. And of course, Dr. Halde, our wonderful youngster, who is always there at our back. Now, let me start straight away because Dr. Halde has given, directive that we have to be very brief because we are running out of time. You see, Azadi ka Amrit Mahotsav, we are commemorating the 75 years of independence of India. And on this occasion, we have a series of webinars planned. This is the second of the series on edible oil, Indian edible oil industry. Now in this association, whenever we select a topic, as Dr. Prakash and Dr. Halde and Dr. Jindal have told, that we select a topic which is of immediate importance to the country, which is of immediate relevance to the country. How we have selected this topic? Because it is at the moment a matter of deep concern with the government of India, because Indian oil industry is the third largest consumer of our foreign exchange reserve at the moment. After petroleum products, petroleum is number one, followed by gold, and third, it is the largest consumer of our foreign exchange reserves, so it's a matter of deep concern. Now that I have been very nicely introduced by Dr. Halde, so let me skip first 7 slides of my presentation. We only speak of me and my, experience and my, contribution to Indian food processing industry. So let me delete one of the, this is, as Dr. Halde has already introduced, that I have a long association with the Indian food processing industry last 42 years, which large number of projects, which is already on my website, you can see almost about more than 250 projects, 57 projects completed on turnkey basis, 89 to projects I provided my detailed engineering services, 146 DPRs for public sector undertakings, private sector undertakings, and so on. So let me straight away start with my presentation. Last one, please, because, hello? Yes. Now present status, let me start with the present, briefly, with the present status of the Indian food processing industry. Go ahead, Vikas. Next one. Next one. So this is the present status. Estimate, no, you are going ahead, because bear with me. Last slide, don't go ahead so fast. Because shall I do it from here? Yes. You see, India produces oil seeds. We have one of the largest producers of oil seeds in the world. 36.57 million metric tons last year. And despite COVID-19 pandemic, we have increased it to 39.9 million metric tons, means an increase of almost about 9%. Estimated soybean production, 11.40 million metric tons, which is not a mean, figure. But estimated demand of Indian oil, that edible oil, is going at the rate of almost 9%. 26 million metric tons in 2020. It is going to be 34 million metric tons by 2030. Edible oil imports till last year was 15.55 million metric tons, valued at 75,000 crores. But it is going to jump to almost double because of the foreign exchange, because of the estimated demand. And as per the figure put up by SOPA, Dr. Mehta's, I read in Economic Times, as far as the estimated figures quoted by Soybean Oil Extractors Association, it is going to be to touch 1,25,000 crores, means almost double in next 1 or 2 years. So that is a matter of deep concern with the central government at the moment on account of the huge outflow of foreign exchange. This import, out of this import of oil, palm oil constitutes 57% of the total oil imports, followed by soybean and sunflower and mustard. So it is again a matter of deep concern, as Dr. Jindal has put it. Government of India is aware of this fact because recently you must have read that 11,000 crore has been earmarked for plantation of palm in northeast region of the country, about which I have deep reservations. Of course, it has been very well thought of by the members of the NITI Aayog. But as a technologist, as whatever you call it, I have a deep reservations. According to me, it is not a good strategy. If I have time, I will discuss separately about it. Next slide, please. Next slide, Vikasa. So, you see, little I am not able to see it properly. Thoda sa adjust kar lo isko, because I'm not able to see the figures right now. You see, in 2020, when we produce, we are the largest producers of oil. And then after oil, we are left with the oil cake, de-oiled cake, which we consume in a large quantity in our own country because we have the largest population of cattle in our country. But despite that, we are left with a lot of surplus, which is exported to a lot many countries in all regions of the world. And total export is worth about 3.68 million metric tons, which is valued at 8,838 crores. And about, you can say about 66% of this is constituted by soybean cake. Next slide. Next one, please. Next one, Vikas.
Just one moment, sir. Doing it.
What has happened? Why am I not able to open my own PowerPoint? Okay. The largest export of the oil meal goes to Southeast Asian countries, mainly South Korea, Vietnam, Thailand, and Bangladesh. And then Middle East countries, value-wise, only 0.72 million metric tons goes to EU, USA, and Scandinavia. But we get maximum foreign exchange from these countries. We talk about the average price in 2019. It was about 33.9 rupees per kg, but it had gone to 40 rupees, 47 rupees now. But gross value of our earnings from foreign exchange has been 17,000 crores. Average price of soybean oil has been 815 rupees per 10 kg, but it has gone almost double now in the country because of various reasons, which is again a matter of deep concern with our government. So gross value is going to be about, say, 6,849 crores. Then, now let me, next slide. Vegetable oil industry in India. Now today we are, next slide please. Let me see my own computer. Next slide please. Next one. You see, today in today's seminar, we are not talking about growing of oil. It is also one of the major concerns, but we have selected this seminar on technology foresight perspectives. How the technology intervention is going to make us get rid of this problem of spending so much huge quantity of foreign exchange on it. What are the technology interventions required immediately? So the technology interventions are to save edible oil industry of India. Now, what are the basic objectives? What are the basic problems? Number one, health hazard, technology interventions to save us from health hazards. Number two, safety hazards. Number three, economic uncertainties. So today's theme webinar, theme talk from me is going to be on thrust on process technology intervention. Next one. COVID-19 pandemic has taught us a lesson. By now, this pandemic, which is still rampaging fast in the rest of the world, other than India, it has already affected 238 million people all over the world and taken a toll of 4.85 million people. And what is the basic lesson we have learned from this pandemic is that where the people who got affected, who succumbed to the pandemic, were the ones who had least immunity response in their body. So if we had better immunity in our body, we could have fought this pandemic better. And what are the requisites for having this immunity in our body, immunity response, immunity strength to fight any kind of onslaught on our health? Is number one, we must have nutritious food. we must have safe food. These are two fundamental aspects. So the body immunity levels are therefore designed to be maintained at an optimum level, which depends on safe food and nutritious food. The definition of safe food is it has to be 100% free from harmful contaminants. In case of edible oil, the raw materials, whether it is oil seeds, nuts, seeds, nuts, soybean, and bran, it has to be free from pesticides, residues, and harmful contaminants. The edible oil should be free from unhealthy trans fats, but Dr. Adulterized and adulterations. Adulteration is important. The milling of oil seeds must be done at low temperature because when we use expellers, we use extruders, they generate heat. It removes all the nutrients, most of the nutrients from oil and oil residue and solids. The solvent extraction process to recover oil from all over the world, the solvent used is normal hexane. By a safer, it has to be replaced immediately by a safer alternative. As its vapor presence in the environment around due to diffusion is a potential health hazard. It is highly neurotoxic. The recommended ppm level in the environment should be about 50 ppm, but above 1000 ppm, it is going to be absolutely hazardous. It's absolute health hazard. Then the solvent extraction processes are required to be based on low temperature technology to ensure preservation of the natural nutrients, both in oil as well as the oil meal. Next one, the safety hazards in existing edible oil industry. You see the standards of the environmental health and safety standards for vegetable oil production are available. You can download the website of IFC. The website is EHS guidelines. EHS means environmental health and safety standards set for the edible oil industry. They tackle the raw materials, whether it is nuts, peanut, soybean, olive, palm, kernel, oil seeds, bran. All of them contain oil. All of them contain enzymes. If you don't store them properly, they get degraded, proteins get degraded, and in the process of degradation, they generate gas, which is mostly methane, and with a slight, carelessness, it can explode. So to save this, you have to have the proper storage, and for that proper storage, you have to have proper technology. Under what process parameters the storage of all these raw materials for edible oils need to be stored. If you are careless in storage, then you are in for a trouble. You get bad quality of oil, you get bad quality of the oil meal, and then it is a safety hazard also. It can catch fire. Then at the same time, this solvent has to be safe other than normal hexane. Explosion, in fact, it becomes normal hexane. You see, if you don't store it properly, if you don't handle it properly, if you don't transport it properly, it is a potential safety hazard because it is a highly inflammable liquid. Its flash point is only minus 26 degrees centigrade. You can understand that at ambient temperature, it can be highly hazardous. And these hazards we have been reported even from the advanced countries. If you download the website, you can see that serious explosions have taken place in Italy, Japan, as well as in USA out of the explosions from normal hexane. The safety hazards in next slide. Now, conventional technology for extraction of edible oil, everybody knows. We have to prepare the raw material, means pre-processing, mechanical, then followed by mechanical milling for extraction of oil, then subjecting the oil cake to solvent extraction process to extract residual oil, then refining of crude oil, which involves processes like desolventizing, degumming, neutralizing, deodorizing, and then drying. Then we are left with the residue. We have to dry the residue, cool the residue, condition the residue before it is available for sale, then packing of the finished products. Now we have in this webinar, I checked up, we have a lot of participants from the industry which is other than oil industry. So for their sake, I have given 3 simple process flow diagrams so that they can understand the oil industry, what are the process technologies involved. The first one is process block flow diagram for oil seed treatment prior to solvent extraction process. For example, I'll run quickly through it. For soybean, we go for bean drying, tempering of the beans, cleaning, cracking, dehulling, conditioning, flaking, and then the cake goes for solvent extraction process to extract oil from it. Then for canola seeds or any other seed, for canola in particular, we have cleaning of the seed, preheating, flaking, conditioning, then milling through extrusion or general milling process, wherefrom we get first oil extract, and then we are left with the oil meal, which contains a lot of oil, and that is sent for solvent extraction. Then we have sunflower oil. Cleaning, instead of preheating, we go for dehulling, and then preheating, then flaking. Instead of conditioning, we go for flaking. Then again, the process is same, milling through extrusion or expeller, and then we are left with the oil cake, from which goes to solvent extraction process for extraction of the residual oil. In solvent extraction process, in layman's language, I tell you, the oil cake is mixed with, the solvent, then separated, filtered. We are left with the solid residue, and we are left with liquid residue, which is solvent plus oil. Solvent is evaporated and recycled back for the process, and then we are left with crude oil, which is then subjected to refining. And the solid residue, it also has a lot of solvent, inherent solvent in it, that is heated, that is cooked, so that solvent releases and it is recycled back. And then we are left with the de-oiled cake free from solvent traces, maybe if yes or no, and then that is going for sale. We have another extraction process, that is supercritical extraction process, which is of no commercial value because it is only for niche products, which are high valued products, because it's an expensive process. It is a batch process, expensive process, in which we subject the oil containing raw material to high pressure solvent supercritical extraction under carbon dioxide or nitrogen or whatever, liquid nitrogen at very, very low temperature of less than minus 150 degrees C. So we are left with oil and gas, if liquid form. So gas is evaporated, recycled back or flushed away in the air. And then we are left with the carbon dioxide goes back to, if we want to recover it. Coming back to this was for the people who are not associated with oil industry to understand what are the basic parameters of technology involved. Now, what is the technology foresight? We must plan for the Indian oil industry. Since edible oil is the most essential cooking medium for all kinds of food preparations, it is expected to be free from traces of any toxic contaminants as well as the potential health hazards. The oil and oil meal produced should be of high quality standard. The process technology must ensure that active high extraction yields as much as possible. We recover all the oil from the raw material. Then the capital cost as well as the operating cost. The technology, basic parameter of technology is not that we have, state-of-the-art technology, but which has no economic basis. So the state-of-the-art technology has got to be such so that the capital cost of the project is relatively lower, and the cost of production costs are also compatible with the conventional technology, so that people can invest in it, so that they get attracted. The consumption of utilities and manpower should also be lower, so that the economy, becomes superior. The unit operations should be equipped with automatic control systems as SCADA, with other peripherals devices like PLC and PID controllers to have interface with the process plant machinery to minimize the human error to the maximum extent possible. Last but not the least, the technology foresight of the modern solvent extraction units are expected to be safe and environment friendly. It is not that we talk about health hazards or other things, but the economy or the environment has also to be safe. It shouldn't affect the environment around. So there are three basic technology interventions. Number one is that solvent is the culprit. It is a potential health hazard, it's a potential safety hazard, it's a potential environment hazard, and relatively uneconomic in its operation. I will explain it how. You see how I got this idea about this hexane. I had the pleasure or displeasure or whatever you call it of going through a book is written by Steve Demo, founder of White Wave Foods, on hexane extracted soy protein. He has titled the book, next slide please. He has titled the book, "It is the dirty little secret of the natural food business." The book has been published by Cornucopia Institute of Wisconsin, USA. And it says hexane, the processing of natural soy with neurotoxic pollutant. I would request all the participants to note the author and the book and the publisher so that they have the opportunity to go through it by themselves. The breakthrough in technology has already come. And it is very interesting to explain the breakthrough in technology. Breakthrough in technology, the breakthrough technology from XALT. XALT means extraction alternatives of USA. When I read this book, then I thought that what to do about it. I scanned the literature all over the world and found that there is an institute, R&D institute in USA, who have done a lot of work in this. So I got myself connected with the institute and found that there has been a technology breakthrough in the technology, this solvent extraction process for edible oil. They have been able to replace this normal hexane by an absolutely safe, low-density gaseous solvent, which doesn't leave behind any traces in the working environment around or in the finished products or byproducts. The edible oil obtained through this new technology route is of excellent quality with all its natural characteristics and aroma fully reserved because it's a low temperature technology. There is no heat generation anywhere involved. And the solid residue that is left behind, there is no degradation of molecular structure of the protein. So you can use it as a protein, and this protein you can feed even to the infants. They can also digest it. So it is a high valued product, not a simple soybean or a de-oiled cake which you feed only the cattle. You can also feed this to the human beings and solve the process of malnutrition. Here is the comparison of the two solvents. Now you see normal hexane is its physical state under ambient condition is a liquid. Solvent, the gaseous solvent is a gas. Boiling point of hexane is 60 degrees C, and this new solvent is minus 35 degrees C. Then since you have high temperature in solvent extraction process using normal hexane, so permeation in substrate, you need higher temperature, whereas in case of this gaseous solvent, it is natural permeation, easy sparging. Desolventizing, for desolventizing, you need to heat the product in case of hexane, but in case of this gaseous solvent, you don't need to heat the product. It is done at lower temperature and lower vacuum. Solvent losses are minimal because of high temperature. If you see the environment around the solvent extraction, conventional solvent extraction plants, there is diffusion because of high temperature. Normal hexane you can see is around ppm levels are maintained, of course lower, but it can be a potential health hazard. Whereas in case of this new technology, it's a totally closed system and there is no gas leakage, whatever. Then health hazards, as I explained already, the residual contaminants There are in normal hexane, they have found in Japan, in USA and EU. They have found that DRR hexane is found in traces. And then,
Mr. Cole,
I
sir.
will take another 10 minutes. I am the key speaker. Huh?
Yeah,
From
Mr.
no
Cole, sir.
traces are safety hazards. So doubtful and assured through spirit technology. I'll run through the slides. Don't worry, moderator. Huh? I value your time, but I will run through the slides now.
Okay. Thank you.
So they have found in the other countries that exposure to air contaminated with normal hexane in conventional plants causes dizziness, nausea, headache, weakness, blurred vision, and even numbness. They have found the animals fed on de-oiled cake from normal hexane-based soybean extraction processes develop neurotoxicity in animal. So the EU has already laid a standard of gradual rejection of the imports of soybean de-oiled cake in case it is produced through normal hexane, and they have given a time-bound program to eliminate stop exports altogether. So ambient temperature extraction solution, I have already explained it. At its simplest, the system takes advantage of relative affinity. This is, the gaseous solvent, it takes advantage. It has a relative affinity with the lipid. It removes the lipid and leaves everything safe as it is. No, problem with the natural material present over there. It simply abandons the leaves, stems, seeds, only removes the oil. The system has been is a low pressure system, low temperature system, generally recommended as safe. Both expeller, extruder, and hexane operate at higher temperature because they generate heat and affect the quality of the oil as well as the de-oiled cake. We are for the listeners, please note that we are going to publish this paper in Indian Food Packer. In case you missed, in case I am made to rush through my presentation, you can read it, the whole article in the Indian Food Packer later on. And maybe we keep it on the website also. So these conventional hexane process you are already aware of. State-of-art process, this extraction alternative technology, process plant and machinery, I have already explained it. The best part is it is a custom designed plant. You can plan the construction and modules. You can have 1 TPD plant, you can have 1000 TPD plant. It can be constructed like that. So the process plant design criteria is determined by the raw material, by location, by end use, and by the climatic conditions at a particular place. So it can be custom designed. So for which we are the technologists, we are the engineers. If you feed the parameters, we can design the plant for you. Then the oil extract is naturally pure, as I explained, with all physical and chemical properties preserved. 70% laminate oil cake produced through this low temperature process rather more valuable than the conventional oil cakes. Primary nutrients, sulforaphane, remains fully preserved in this process. Raffinate remains free from oil and devoid of any traces. Then you see other salient features, they can be explained. I have explained it. Maybe if we are left with some enough time in this question answer session, I can explain it that time, because otherwise Dr. Halde will press the bell. Huh? So another salient feature of this technology is that other than oil extraction, it can be applied to all culinary herbs, vegetables, and aromatic plants, so that you can remove the oil and leave the plant as such, which can stay shelf stable under ambient conditions. Like this is the picture. The picture. Show the picture. Vikas.
Which slide?
Move the slide. Show the picture. Next picture, which comes on the slide. Rush through the slides. Rush through the slides. There's a picture. A technical brief beyond oil seed. Next one, next one, next one. Yes. So this is a picture of the same technology applied on cilantro. Cilantro means Korean. Dhania, dhania in our language. So they are subjected, this cilantro is subjected to this oil extraction process. We remove the oil, it can be sold separately, and the leaves which are left there are shelf stable under normal ambient conditions. And same can be applicable. You don't need any freeze drying or anything. They remain as fresh as farm fresh without any application. You don't need refrigeration. So this technology can be applied to all culinary herbs. You don't need freeze drying of the herbs. You don't need any extra thing. So you can have long shelf life of all these culinary herbs, aromatic plants as also. So it is an added advantage. You can use this process for after oil season is over. You can use this process for many other applications. Then technology overview, I have already explained. Next slide, please. Separation of lipids from wet and dry separate. Performance at 20 degrees centigrade. Low pressure, 130 psi, 8.85 atmospheres. Recapture and reuse of gases for maximum efficiency, and so on. Technology overview. Then you see the quality of the oil, which we have produced from this technology. Technology comparison, if we say that expeller and extruder products get damaged through exposure to excessive heat, oxidation, pressure and shear, and exposure to water. Partially denatured dry fraction, incomplete recovery of lipids, crust cake is a waste. Then if we use hexane extraction, then incomplete recovery of lipids, product damage through exposure of high heat, solvent contamination in finished products. Hexane is listed as carcinogenic, neurotoxic, air pollutant in USA, Japan, and EU. Carbon dioxide, we don't. So this is the technology comparison of all the food processes. Now you can see from this next one. There's a picture of soy flakes because next one, please. Yes, you can see the color of the soybean flakes. It is absolutely white when produced through this technology using gaseous solvent. Second one is the through extruder. It is partially cooked and partially burned. Then if we use the expeller, it is totally cooked. You see it is totally black. So you see the comparison of the three technologies. Then this, yes, capital cost of this technology is also minimal. We can say, as I explained, we can have a plant with a capacity of $1 million to 100 million. It depends on the capacity, what capacity we design it for. Capital costs and operating costs are low because we are not using any heat. We don't use any steam anywhere. Only utility required is power and nothing. Then degree of automation is as required by the buyer. Initial lab testing is required so that we can custom design the plant. Then the plant design features are designed. See, we use turbulent flow extraction in this technology. So it gives maximum solvent to raw meal surface area contact. So maximum separation of oil which goes with the solvent. Then we can optimize this for a capacity of below 25 metric ton plant to any size. The simpler modular design saves time and money on construction. You see the comparison of the two oils separated through this technology. I thank you all. I thank you everybody for your patience to listen to my technical talk. Dr. Halde, I wish you had given me more time to explain more and more aspects of the technology interventions for that are required by the Indian Indian oil industry to sustain in the near future. With that, I revert back to Dr. Halde to continue the proceedings of the webinar. Thank you so much. Thank you. Dr. Halde.
Thank you, Mr. Kaul. I believe Dr. Halde is having some connectivity problems, so I will request Dr. RBN Prasad to please continue with his presentation, please. You need to unmute yourself, Dr. Prasad.
Yeah, I'll do that.
Hey, can I start? Am I audible?
Yes, yes.
So my slides are visible? My slides are visible?
Not as yet.
Not as yet.
Not yet?
No, you just try and link it again once more, please.
Could I put to see on my screen?
Yes, now it's visible.
It's visible? Okay.
Yes.
Yeah. Good evening to all, particularly Dr. Prakash sir and Ms. Paul sir, and also Dr. Vatke and Dr. Jindal and Ms. Prabodh and all other participants, and also the senior industry friends. See, basically, I'm trying to, in the next 20 minutes, I'm trying to talk about particularly with respect to physical refining, what is the real way forward. Because already, what you call Mr. Paul was telling that it's really a problem for us. We're importing so much of this thing because we have numerous applications, but how to manage, that's a real issue for us now. See, the major challenges are now is the most neglected area in India, particularly oils and fats, and never enjoyed the importance either in the professional or education in the university courses or in chemistry or chemical engineering or biotechnology, or also in the frontier research. So basically, it's a totally, unfortunately, it's a neglected area in the country. And at the same time, what is really happening, the applications are increasing. Say, for example, some time back, the ratio of food, feed, and industrial use are 80 is 66 is to 14. Now it has fallen down to 74, and the industrial uses increased to 20% because of biodiesel. Particularly in our scenario, all of us were talking now stagnant production and increasing imports. See, basically, I don't want to tell everything. Particularly, I want to tell that last 10 years, so we are lingering between 7.7 to 8.5 billion tons of oil, and also not more than 5 or 6 oils are the major. But at the same time, our imports are really increasing. Already we have told by several people. So basically now what I would like to really tell here is, see, basically now globally, when we are looking at, we are producing around 220 million metric tons using 280 million hectares. But whereas in India, we are producing between 7.5 to 8.5 million metric tons using around 28 million hectares. It's a huge area, but unfortunately stagnant for last 10 plus years, even though the global growth is about 3% per year. So look at Malaysia, they are producing around 20 million metric tons using 5.4 million hectares, whereas we are using 28 million hectares, producing 7.5 to 8.5 million tons. And Malaysia with 5.4 million tons, 1/5 of our land, they are producing 3 times of our production. See, basically we are restricting to few crops. We are unable to really increase the productivity for last 10 years. So now I think we need to, our agriculture sector need to really look at, is it really we are going in right direction? So my feeling is Malaysia, they have used the appropriate for their soil. I think it's an opportunity for us to really look at, to choose an appropriate oil seed for our soil, because we have a lot of forest area, so many oil seeds. I think we may have to really look at in the direction to really look at an alternate crop. See, coming to my presentation, so basically I am trying to really look at, when you want to really see, that's a productivity you can't really increase from agriculture point of view last 10 years. So some sort of peanuts type of thing can we really increase from the processing. One is extraction, second thing is refining. These are the 2 areas. extraction already, Mahotsav already he was mentioning. So, but here the thing is there is some scope. I think even Dr. Vatke also is going to speak on that. But I would like to include only one point here. See, particularly when you really use the enzymatic treatment, it breaks the cell walls. So you may not really what you call use for every oil seed, because it's a really nuisance of really what you call extracting oil, actually aqueous extraction. But thing is, recently they are claiming that enzyme palmora, there is a combination of cellulose and hemicellulose. When they really use this particular enzyme in a pre-cooker before digestion of the palm oil extraction, so the minimum oil of minimum 0.5% they can really extract, because see, globally we are producing around 60 million tons. So 0.5% is not a small amount. Of course, in India we are not. We are producing around 3 lakh tons. It seems a couple of mills they are already started using this particular enzyme. So we need to look at this type of what you call techniques, how to really increase the what you call oil. Coming to the refining, basically I would like to really emphasize on one of the process, enzymatic degamming. It provides a commendable opportunity for the efficient physical refining and also for higher yields of oil, because we cannot really increase so much even during refining also, but at least enzymatic degamming gives an opportunity to increase the oil content, at least no losses, at least up to 1 to 2%. So that's the reason. I think this is one of the area. Once we need to really look at it. It's ripened technology now. So of course I don't want to really tell, because basically there are physical and chemical refining. In chemical refining, generally we use soap stock as an alkali treatment, soap stock. In physical refining, finally at the end of the what you call process, we distill out the fatty acid to get the refined oil. See, but the thing is, basically for the physical refining, good physical refining, very good pre-treatment is really required. Particularly, the phosphorus content should not be more than 5 ppm. See, compared to chemical refining, of course, still chemical refining is being practiced. But why physical refining is physical refining loss are only 1.1 times of FFA, whereas in chemical refining 2.5 to 3 times of FFA. That's the reason. In any case, now the whole world, if anywhere it's a more than 5-6% FFA is there, everybody is really employing physical refining now. But only thing is, when somebody employs the enzymatic degamming, they can increase their yields and the process becomes a little bit more greener. So, and also the physical refining, it retains most of the nutritional components. When you use alkali, like tocopherols and other things, they get extracted out in the soap stock. So actually industry was struggling till early 2000s due to the non-availability of appropriate pre-treatment for particularly a degamming process. So there are some other problems in physical refining. See, particularly when you go for physical refining deacidification, you need to really use the higher temperatures. The higher temperature always they may create the oxidation of the products if the vacuum is not proper. And also during thermal isomerization, we might get the trans fatty acids. That's really happening, particularly rice bran oil. We need to really use very high temperatures. So that's one of the real challenge for the technical people to really come out of this, because in India now, from the January 2022 onwards, the trans fatty acid must be less than 2%. So several oils still, particularly rice bran oil, soybean oil, there is a problem of crossing 2%. So one has to be very careful because in another 3 months time, so this bell is ringing from the Indian government. So similarly, comparatively, we are getting another new problem now of late. Today morning itself, we have a consultation with the industry association by FSSA regarding this MCPD and glyceride esters. It's becoming really an issue. So basically here also in this case, by chance, if the crude oil is getting contaminated with chlorine and also mono and diglycerides, so there is a possibility of conversion into MCPD and glycerol esters during the dewaterization or deacidification. That is the reason one has to be very, very careful about this particular dewaterization and deacidification of late now. So coming to what you call now, I want to really show a few slides, because these are the efforts of our group at IICT regarding the rice bran oil. I think now I'm lucky to have Prakash sir along with us now. So he was the person who really almost started motivating the whole country through SCA platform, through CFTRI. So how to really come out with a wonderful oil of Indian oil of rice bran oil. So basically there are several challenges of rice bran oil, like it's a different oil compared to other seed oils like soybean and sunflower. So generally after removal of the bran, the moment it comes out from the grain, it has an enzyme lipase. It goes on triggering because of moisture. It goes 4 to 40% within 15 days FFA. So that is the reason a lot of issues are there. And also because of the free fatty acid generation, monoglycerides they form. Unusually, it contains high content of wax, something like 3 to 4% of wax. And also it contains polar lipids like non-hydratable phospholipids and glycolipids. And also it contains high content of unsaturated like hydrocarbons, sterols, tocopherols, tocotrienols. And also sterile esters, it contains around 2.5%. And also oryzanol. And also this dark color is due to a lot of pigments present and also oxidized lipids in the rice bran oil. That is the reason it was a real problem for industry to really treat the to really process the rice bran oil. See, at that time in early 2000, this enzymatic degamming people started really talking about it. So basically, water degamming is a very simple method for removing phospholipids, but the problem is water degamming removes only hydratable phospholipids. So residual non-hydratable phospholipids will become something like 100 to 200 ppm. They will not come out. That is the reason people use phosphoric acid and a very high dose of phosphoric acid. And due to that, a lot of other issues. So that is the reason at that time people started thinking about alternate methods. So traditional degamming methods like phosphoric acid, already I told you, it's very difficult to get less than 5 ppm. Even if it succeeds, it's not a clean process. So whereas enzymatic degamming, it hydrolyzes phospholipids, including non-hydratable phospholipids, and it becomes water soluble lysoleucine. After hydrolysis, when you centrifuge it, the soluble, particularly hydrolyzed lecithin, it will come into water, fraction, so very easily. Then oil does not contain the phosphorus. So basically, there are 3 enzymes people are using now. One is PLA1, whereas so PLA1 phospholipase A1, it will be at 1 position. PLA2 at 2 position. It leaves the fatty acid. It forms OH group. That means lyso group. And also PLC, it cleaves at the just before the phosphate moiety. So you get the diglycerol. So off late, the new innovation is phospholipid C. I'll tell you in my future slides. Basically, when you hydrolyze it, so basically what really happened, the fatty acid comes out and it forms the lysophospholipid with OH group, which becomes hydrophilic. It slips into water. So when the enzymatic degamming story started, people started using the phospholipase A2, which was isolated from porcine pancreas, because sentimentally it's a non-veg, it's very tough. But in those days, porcine pancreas started using in a very, very a small sector. But after that, let's say Novo was introduced by Novozymes in early 2000. So then the people started thinking about, but people did not succeed. Then at the time, IACT, my group, we started working. We procured the enzyme from Novozymes, and we have optimized this process at 10 ton in a local industry, Hyderabad. Then after that, we transferred this technology to about 25 industries. So we really worked very, very, very hard in those days. Of course, it was protected by patent in several countries. So basically, the advantages of enzymatic degamming are no complex processing step. It can be implemented with minor modification in the existing refineries. They need not really do any sort of major capital investment. It can be converted into a continuous process very easily. And phosphorus levels in the pretreated RBO can be brought down to 0 to 5 ppm without any problem. If it contains 1 to 1.5% of gums, the oil content is not more than 20 to 25% in the gums. Generally, oil content is 50 to 60% in the gums. Whereas when you use enzymatic degamming, whatever the gums you are resulting, so only 20 to 25% is there. And also the gum content will really come down. That's how you save something like 1 to 2% of oil. So there's no alteration to fatty acid composition. and water wash is not really required after enzymatic degumming. And other unit operations are like bleaching, dewaxing, deacidification. They become very, very smooth. And also original of the crude rice bran oil, which is a wonderful component, it remains intact. Whereas in chemical refining, when it contains oil contains about 1 to 1.2%, it will drastically come down to 0.2 to 0.3%. Whereas in this case, it will not come down not more than 5 to 10%. So actually, this technology has been transferred to 27 clients from 2002 to 2008. And at that time, the government of India, under the technology mission, they gave to 15 industries a 75 lakhs grant in aid using ISC technology, and about something like 11.25 crores was given. So something like around 2 lakh tons of dark colored in those days, when 2000, when we started this particular technology, transferring technology, India was producing not more than 2 lakh tons. That too, it is a very, very dark colored oil. But when enzymatic degumming comes into picture, then we started getting very good oil, and also within 3 to 4 years time, and about 2 lakh tons of fresh oil came into picture. So that much oil was India could able to really produce. Today, when we started our journey at 2 lakh tons, today India is producing about 11 lakh tons of 5 times in 20 years time. With a wonderful oil, we are exporting to several countries also. And out of 11 lakh tons, I'm very happy to say that 60 to 70% of the oil is being processed using enzymatic degumming technology. So I would like to show this for the sake of the confidence of the industry. So in 1998, when the first national seminar that Prakash sir was also there, was organized by SCA in Hyderabad. So Dr. Sharma was telling at that time, basic requirement of physical deacidification is that the phosphorus content in the oil should be less than 5 ppm. So far, no commercially viable technology is available to achieve the desired levels of phosphorus. The only way by which phosphorus content can be reduced to the minimum possible level is continuous degumming followed by bleaching with heavy dose of neutral health ranging between 7 to 8% with 0.5 to 1% activated carbon to get the better color reduction. RBO color at that time of deacidification was 25 to 40 units. But in September 2005, in another SCA meeting, the same Dr. Sharma was started telling AP Solvex and AP Organics could be able to achieve zero phosphorus in the feed oil of the deacidification with just 2.5% bleaching it without carbon by employing enzymatic degumming process. Color after deacidification was 12 to 14 units. Today, people are getting even 7 to 8 also. So, C.R. Sharma was the first one to implement the enzymatic degumming of the ISC technology. So that's how this particular technology has been really percolated. And I think in this direction, we need to really work further. Why I was really telling is at the time, even government also really supported. I think at this stage, even government's role also, it's very, very important. I think now in the next 3 to 4 minutes, I'll try to tell about what are the new innovations in the enzymatic degumming. Previously, it was phospholipid A1 and A2, and now phospholipid C it came into picture. See, when you really react the phospholipid with the phospholipid C, what really happens at the third position, the phosphate moiety comes out and you get diacyl glycerol. Diacyl glycerol is soluble in water. That means you are not producing the gums during degumming. That is the beauty of phospholipase C. So when you are really using phospholipase C, straight away you're getting phosphate is going into water, the diglyceride is going into oil. So that's how you are really you be able to really get still higher yields compared to the traditional degumming. So basically using phospholipase C, you get diglyceride and phosphoesters. So this loss is relative very, very low compared to even the traditional phospholipase A degumming. When you employ both the things together, I think still a lot of wonders will happen. So in this case, when you have 1% of phospholipid, 0.8% will become the diacyl glycerol. That means you are not losing any even phospholipids also. So in this case, when you use phospholipase with 1% of phospholipids are there, you get 0.36%. So that means almost double the quantity. It is you're saving into the oil because the diacyl glycerol also is good for health. Nothing to really worry. So basically now the crude oil, when it contains 100 to 1500 ppm, you can use full degumming with VLA, or you can do full degumming with VLC plus PLA. So otherwise you can do water degumming, you can collect the phospholipids. After that you can do either PLA or PLC. Even now, the another advantage, some people are really what you call fond of chemical refining, particularly soybean and sunflower oil because of color. Even those people also, they can treat with the phospholipase C. Initially, even PLA also, but PLC is better. After that, if you can really do the alkali degumming, then you can save minimum 1 to 2% of oil. That way, indirectly, whatever you are losing, 50% of the oil, when you are losing 2% now, you can lose only 1%. If you're losing 3%, you can lose only 1.5%. So that is the advantage of enzymatic degumming. I think you should really, what you call, industry must really consider very seriously. Of course, this is a representative case studies provided by enzymes. So basically, when they say when you do acid degumming, you lose from every ton, you lose around 30 kg of when the crude oil contains 1.5% phospholipids, you lose 30 kg of gums. Whereas when you use the PLA1, you lose 17.5% of gums and 4.5 kg of free fatty acid. But when you use PLC, of course I misread here. When you use PLC, you don't get gums. You get you don't get FFA. You get only phosphate ester there. So when you use Listrase Ultra and also Cura Boost, that's PLC of Mahotsav, you get something instead of 970 acid degumming, you get 990 kgs. That means 20 kgs extra. That means 2% additionally you are getting what you call oil. So similarly, when you have 2.5% of fruit phospholipids, again 50% less when you use the enzyme along with the alkali, you get more compared to the traditional alkali process. That means minimum at least 1 to 2% more recovery one can really get when you use the what you call enzymatic degumming process. So today the status is about 50 to 60 grams of PLA1 is required for every ton of oil. That means we don't require not more than 100 to 120 rupees for a ton of what you call oil to treat the enzymatic degumming. Originally it was quite expensive. Now several companies are making it. It has come down drastically. Similarly, PLC, it costs about 200 to 400% because in this case you are getting more oil recovery. So that is the reason it's worth to really use it. See, today you must be observing phosphoric acid cost has become 200 rupees a kilo. So that means now when you really do implement it properly, it's indirectly becoming cheaper even compared to phosphoric acid also. So enzymatic degumming provides the trouble-free unit operation. Beauty is after that trouble-free operation like bleaching, dewaxing, dewaterization, deacidification steps. Now already I told you about 60 to 70% of rice bran oil is being processed using enzymatically in the country. Few industries started implementing the enzymatic process for soybean and solvent extracted mustard oil refining also. So industries started implementing enzymatic degumming even for the chemical refining also for more recovery of oil. Globally, about 10% of the chemically refined oil using employed using the enzymatic degumming approach. Whatever it is, when people use, they get minimum 1 to 2% of additional recovery is really possible. So I think I'll skip this particular slide, and several people, they started from the starting feedstock to the particularly packaging. So there are several ways we can really what to call implement. So everywhere there is a possibility of really enhancing the quality and also the losses of the oil. I think now we need to really what to call look at least, even though we are unable to produce for last 10 years, not more than 7.5 to 8 lakh tons. At least if we can save 1 to 2 what you call percentage of oil, at least we can save a little bit of foreign exchange. I think we can't do anything more than that. Thank you very much. Once again, I thank the Food Processors Association for providing me the opportunity to share some of our work which was carried out some time back. Thank you.
Thank you, Dr. Saad, for your wonderful presentation. I would now request Dr. Vache to please share your presentation and please share your views with the audience, please.
Yeah, Vikas, do I have the authority to share my screen?
Yes, you can. Now you can share.
I have
given you access. Yes.
I will try. Thank you very much. Okay. slideshow. Guys, come down there. Are you able to see my screen?
Not yet. You first have to click on share screen at the bottom of the screen. Then you have to click on your presentation.
Single.
Yes,
Is
we
it
can
better now?
Now we can see it.
All right. Good evening to everybody, dignitaries and all the participants. I will be speaking on vegetable oil extraction and be covering both the mechanical expression as also solvent extraction. But before I go on to that, if I can make a couple of comments. In his opening remarks, Dr. Prakash mentioned that the thrust or the focus of this webinar could be to show a pathway for self-sufficiency in vegetable oil. I must say here that the self-sufficiency or the lack of it is not because of absence of oil processing technology in India. It has solely to do with agricultural economics and agricultural environment. The Solvent Extractors Association is now working closely with the government of India to enhance oilseed production. And the thrust areas right now are two. One, to increase productivity and area for mustard, which is our mainstay in North India. And second, to encourage large-scale plantation of oil palm, especially in the Northeast and Andamans. And that's where I come in with my second comment, because Mr. President, you made a comment on palm oil, and I quote, "Palm oil has been proven to be not the best." I'm sorry, I must differ here. I do not want the participants to go away with an impression that palm oil is a bad oil. The fact is, palm oil is also a natural vegetable oil and is as good or as bad as say, soybean oil. Having made those comments, let me get back to my presentation. As you can see on the screen, I'll be talking of the status of technology in India. One, the progresses made in recent times, and where we stand vis-a-vis the best in the world. Now, just give me a half a minute, please. The aspects that I will cover is what have we done on the ease of operation, coming from the days where a lot of manual work was involved and manual interventions were involved in processes and operations, and then the status of automation. I'll also be talking a bit on process efficiencies. Mr. Kaul was mentioning about efficiencies, so I'll be taking from there. Of course, we'll be talking about operation safety. A point has been made in previous presentation that this is an unsafe operation due to use of solvent. I will contest that with status here. And we'll talk of steps taken for protection of environment, even with solvent extraction. Let me briefly talk of the first processes. I will not really dwell on this. We start with seed unloading. In India, the seed is received in bags, unlike in the West, where it is received in bulk tankers. And when we open the bags, a lot of dust comes out. And we have worked now to ensure a dust-free environment using a proper aspiration and bag filters. So in modern plants in India, we now have totally dust-free environment, even in the seed unloading section. Well, yes, on the storage silos, it is used, although mainly for storages. We now have devices to regulate feed to the plant. So our process control really starts from the silos area. Okay, let's talk of mechanical extraction. As you know, there are two methods of oil extraction. One is mechanical press, and second is solvent extraction. We now have, okay, the mechanical extraction is basically practiced on high oil seeds, basically seeds containing more than 30% oil. For India, the relevant seeds are mustard, groundnut, and copra. We now have high capacity modern presses in India. I must say here that with the advent of these high capacity modern presses made in India, we now do not import these expellers. Rather, our companies have been exporting these presses to various parts of the world for the last 10 years. The advantages of these modern presses are many, including low electricity consumption per ton of seed crushed, very easy to operate, no manual work there. These are very safe operations thanks to the closed door operation. Some of you, if you have seen the traditional oil mills in India, the old oil mills with the open cases and oil flashing out, and the whole environment was very risky. Here, thanks to the closed door operation, it is a very safe operation. And of course, very minimum maintenance, thanks mainly to use of high alloy steel components. For mechanical extraction, there are basically two parts in the plant. One is the pressing section, another is the filtration section. And we now use modern oil filtration equipment again, which eases the operation because no manual work involved, and these are very safe. Having quickly run through the mechanical extraction, let me now dwell on solvent extraction. Solvent extraction, basically, a typical solvent extraction plant will have two buildings. One is the seed preparation building, and a conveyor will take the prepared material to solvent extraction plant. The cleaning machinery that is now made in India is as good as the best in the world, thanks to Buehler making those machineries in India. Unfortunately, we cannot say the same about the main heavy machineries, namely the crackers and the flakers. While we have progressed significantly over the last 10 years, there's still much desired on the making of these machines in India. There is the cookers or conditioners, as they're called. These can be designed to the latest and modern designs. We have that capability. And then finally, in most plants today are equipped with expanders, which are also made in India. And they're reasonably good considering the low cost compared to foreign machines. These are quite good. And the solvent extraction plant itself, we now have the ability, when I say we, companies in India have the ability to design solvent extraction plant to the best international standards with comparable process efficiencies. The reason I use the word comparable, I'll explain that in the next slide. And product qualities, uniformity of product and best quality product can be processed and produced from our plants. Although the number of automated plants in India are few, we do have some with stage 3 automation. When I say stage 3, these are fully automated and one does not have to have an operator in the plant. Thanks to design progress and automation, the plants are now safe. And I must say here that sometimes the use of hexane, etc., is highlighted and exaggerated, and it becomes scary. But the fact is, this is used internationally in several thousand plants, and now there are no major accidents over years. We have built-in safeties, multiple safeties. There are 3 safety layers that have been built into design of solvent extraction plants. So now the modern plants that are designed in India are, we can say, are safe. Comparison of utilities and quality. I made a remark in my last slide that these are comparable with the best. These are not really exactly the same as the best, and I'll explain why. Typical figures, because soy is a predominant oil seed for solvent extraction, I had taken the case of soybean. For 1,000 TPD plant, again made in India, designed in India, we have hexane loss 1 kg per ton of seed processed, steam consumption 250 to 260 kg, and electricity 25. These are very good figures, but still not exactly the same as the best plants in the world. Why? One reason is our plant capacities are small. It reflects basically in electricity consumption, higher electricity consumption, and to a small extent in higher hexane losses. A major reason why our figures are not exactly the same as the best in the world is we have frequent start-stops. Major reason being the supply of electricity, I mean, the interruptions and quality of electricity. And then there is a factor of water quality. Please note, we have dust in air in India. This is not common elsewhere in the world. The amount of dust that we have here, that the dust gets into cooling towers, and the water that we use in condensers, then sediments there, necessitating stoppage of the plant to clean the condensers. So for these reasons, the plants have to be stopped periodically. When I say periodically, say once in 2-3 months, but electricity tripping are even today are not done away with. And these are the major reasons why our utility figures are slightly higher than the best in the world. But then we have a silver lining. Again, talking of soy oil quality. When you say quality, especially in terms of refining difficulty, the major factor is the red color. One should note that the red color in oil does not come from the seed. The yellow is native to the seed. The red comes from processing. So the effectiveness and the best practices of processing should reflect in low red color. Typically, in India, in most of the plants, the red Lowy bond quaternary cell would be between 1.5 and 2.5 units. The best plants in India supplied even by companies like DSMET can be 1.2, 1.1, but we now have advances in technology reflecting in very low red color. We have achieved as low as 0.9. That's a remarkable feat. And that reflects directly on ease of refining. And now let me talk of cogeneration and how it relates and how it helps solvent extraction industry. Cogeneration, as you know, is generation of electricity using steam at higher pressure. So at the inlet, we have steam at high pressure, and at outlet, we have steam at low pressure, which is used in the plant. And we have, from the turbine, we have the electricity, which is also used in the plant. That is the way to get over our problem of electricity supply interruptions. Advantages of cogeneration: environment friendly, because the excess fuel used to produce steam at higher pressure compared to the normal pressure is so minimal that it is much environment friendly compared to a separate electricity producing plant. Thanks to the low fuel, the electricity cost is very low. I mean, typically between 2 and 2.5 rupees a unit. And then it helps us overcome the problems of supply interruptions and quality problems in terms of voltage fluctuations and frequency fluctuations. From cogeneration, the electricity we get, of course, it comes out without interruption, and we get consistent voltage and frequency. and we are very lucky. Cogeneration is very, very well suited to solvent extraction because the ratio of steam to electricity that cogeneration can give when we use steam at 45 bar exactly matches. Please note, it exactly matches with our requirement of steam and electricity. So we do not have to waste steam, or we do not have to buy electricity. Both these figures match exactly our requirement. So it is best suited for solvent extraction. Having given you glimpses of the status of technology, let me talk of challenges in front of the industry and the future. Participants, please note, I have run through my presentation. If you're interested in knowing on any one aspect in detail, I think we'll have a question answer session hereafter. I think that the first two speakers and even Mr. Dr. Kaul mentioned the hazards of solvent extraction. While yes, these are the plant's operation is now safe, that the problem of small residue of solvent especially in meal remains. And so what is the solution? I mean, he was talking of gaseous extraction. I will talk of presses. Press design today is limited by if you want to go below 7 or 8% oil in cake, the cake comes out burned, and the electricity consumption goes haywire. So there is a need for a novel design of presses to achieve less than 4% oil in cake. If we are able to achieve that, we could then progress towards green technology. And I must state here that in our company, we have an engineering company, and we have designed a novel press. A pilot machine is ready, and we will start trials very soon. Cogeneration, as I said, especially for India, is the way to go, and we will see more and more plants adopting cogeneration. I did mention about water quality problem. So the filtration of water, continuous filtration, is the way to go. This has been done in about 10 plants in India with excellent results. I did mention you that we have achieved 0.9 red in soybean, but we are not yet satisfied. We want to go down to 0.6 R. Now, what is the significance of 0.6 red? Please note, in refining, the neutralized oil, that is after the steps of degumming and neutralizing, the oil that's produced, the neutralized oil, has about 0.6 red color. And this is the color which is then taken out in bleaching and deodorizing. So we want to achieve this red at solvent extraction itself, so that we do not have to go through chemical neutralizing. If we are able to achieve that, then perhaps we will have a possibility of what may be called organic refining. And that this is also where the enzymatic degumming that Dr. Prasad was talking about would gel very nicely, because refining is all about taking out phosphorus and red color. If we can take out the phosphorus with enzymatic degumming, and with this low red to start with, if we are able to use own neutral earth, then there will be no need to use either alkali or any mineral oil in our refining processes. So we will have a complete organic refinery, simple refining process. Apart from these, we are also exploring a new extractor design, especially for rice bran and palm kernel and shea. Problem with these is due to their low protein, these materials do not hold well in the extractor, and that creates problems, multiple problems. One of them is the high color of oil. So we are exploring a new extractor design which will overcome these problems and can then produce good, nice yellow oil even from, say, rice bran. This is all I wanted to share with you. Thank you very much. As I said, if you have questions, we will be most glad to take those. Thank you very much.
Thank you, Dr. Vatke. I would now request Dr. V. Prakash to give his comments, please.
I don't know whether I can comment on the wonderful talks. That was not my job. The best way to move forward is to respect the technology that we have today. And we are no way inferior to any country and any region in the world. And the second point is what we require today was being very well brought out by all the three speakers. Technology, technology, and technology. All the three have emphasized that. But just like fruits and vegetables, just like dairy industry, it is the backward integration of agriculture, as Wadker correctly mentioned, is missing. And I'm glad that the Solvent Extractor Association of India is really looking at this point with the national perspective. But to do this, it is also important for us to think of the following 5 quick messages. I'm sure this session is being recorded, and we need to take this forward in AIFPA with a focus on the challenges of the oilseed farmer. It's very easy to say, please produce more. What are the challenges that if you grow oilseed, what will you do with it? Where will you sell it? Who is going to buy it? Is there enough demand and so on? So this has been a time and again debate where I have chaired many sessions, but I think still just like the Honorable Prime Minister has declared, doubling the farmer's income. There is a huge potential here in doubling the oilseed production in India, which will add to that doubling the income. It may not be directly, but it will also do it indirectly. And this is very important. And this is very vital as point number 1 when we look at self-sufficiency. Number 2, the technology is never a static one. The technology is always dynamic. And I'm glad scientists like RBN, Wadke and Kaul and others and the Solvent Extractor Association of India, everybody is looking at the cutting edge technology. And that's India. And therefore there is no botheration about it because it's on a well-oiled, well-greased track. But however, a little bit relaxation will put us behind. I like what he said about the index of 0.9. Our target is 1.2, but if we become compliant on that, the world will be taking over us and claiming that here is a better technology. That is also inclusive of carbon neutrality, energy neutrality, and consumption-wise. And I think in here, one may think of solar and so on, but how practical it is a very long-drawn process. Therefore, my second suggestion is to look at an integrated approach of using the byproducts as much as the main product of oil. Rice bran oil is a great example to show that. 1994, when Mr. Goenka arranged the Rice Bran Oil Symposium in Hyderabad, I inaugurated it. First time ever, the first symposium in rice bran oil, when I mentioned India is rice bran oil and rice bran oil is India. But that doesn't mean everybody will eat rice bran oil. But here is a potential unexplored, unexploited. And today we know where India stands. It's number 1 in rice bran oil. So I think it is a question of triggering a mechanism for self-sufficiency. And the multiple oil is the brand equity of India. Different regions only use certain amount of oil, certain kind of oil. They will not agree with any other oil because it's a food culture. Please remember that. Number 3rd point that I want to mention very importantly, the role of oils and fats, not many have mentioned, is so important in our daily diet that not only habit, but also the role of metabolism in the body. Cut off oil for 2 weeks, you may have a brain damage. It is so important, and I think medically, nutritionally, both in the International Union of Nutrition Science and other places, we keep telling don't forego your oil component of the diet, because body requires, according to the reference point, 20 to 30% of our calories, about 2,500 calories per day, has to come from oil. So you can't starve the body and say, I'm going to be lean, wean, and so on. You'll be also weak mentally and physically. So I think the requirement of oil from a medical point of view has to be taken and emphasized more and more, that oil is healthy for you because it carries vitamins, so fat soluble vitamins all the way. The third aspect that I would like to focus along with the medical aspect is the functionality of oils and fats in food processing. It is always seen, India is a snacky country, a large number of snacks, and those who manufacture snacks are looked upon with a lens that they are culprits, they are adding oil to our food, they are adding unhealthy oil. I agree with trans fat, but the point is, oil is a functional ingredient of food processing. Please remember that. Oil is a functional ingredient. You cannot really replace that oils and fats from other things. Bakery, chocolate, confectionery, frying, toasting, seasoning, and encompassing a variety of fats and oils in different natural materials, obviously has to be looked at with a careful fine. And food cannot be devoid of oil to lessen the calories. Moderation in use is more important than overusing with richness in the pocket. I think it is not necessary that you can use more oil than what your body requires minimally, unless you have the capacity to burn. So therefore, those who are indulging in tongue twisting oil into an overuse must refrain to make sure that doesn't send a wrong signal, right? Just because some people are obese, that doesn't mean a normal person should also be devoid of oil. No, medically it is wrong. We require a minimum of approximately 20 to 30 grams. And even WHO says 20 to 50 grams, 50 grams oil per day, provided you also have the capacity to burn. That is also there, and moderate exercise. Therefore, my last point is the following. It is important to bring in awareness and consumer education on the one side to consume oil which is healthy. And I tell you, no oil is bad oil unless you make it bad. Otherwise, with a fantastic process, what Dr. Wadke and RBN mentioned and Kaul mentioned, if you keep strict to a lot of processes, you are getting a correct oil that need to be really appreciated. But if you overuse it, you are now missing the link. Therefore, the nutritionists and food scientists around the world also look at the regulatory aspects of upper levels, which need harmonization on science-based rationalization underpinning food safety. A food containing oil cannot be labeled as red, as though it contains meat or fish or egg or whatever it is. Oil is important. At the same time, the role of food culture, traditional food systems, generation of wisdom has to be recognized and has to be uplifted into the highest level of scientific premier data that the current lifestyle demands. We need to really especially focus on traditional foods, as snacky items around the country is not a crime to eat because it is a culture, provided we have the aim to reduce the oil to the extent we can burn. Lastly, I want to focus back on the first point in terms of a healthy diet, in terms of an individual, and at the same time, the oils and fats and the coconut oil, which was declared by the whole world as a very bad oil, suddenly changed the game when virgin coconut oil was introduced, which is the traditional oil in India way back, if one looks at it. And therefore, where is the world now? Where are those people who are commenting on coconut oil? They're all quiet. They're all quiet. They don't even attend AIFPA symposium. Why? The data has shown What did it show? What was it that was shown? Is the data. So scientific data is very important. And in that aspect, hats off to the technologists who are toiling day and night, and also many, many industries, including very innovative industries. We should not really forget the backward integration. Just like we say conserve petrol, can we say conserve edible oil today because we are importing? No way. Because you require oil for your health. A healthy human being for a better immunity requires a minimum amount of oil through which vitamin A, D, E, and K has to go through, and many other reactions. So therefore, dear friends, dear technologists, scientists, nutritionists, very important to realize that the only way is to include oil seeds in the green revolution net and make it happen. Our industries have the capacity to almost absorb double the capacity of the production. So if our target is going to be 50 million tons by whatever is the year, I would put 2035, the United Nations Food System Summit also declared that you need a healthy diet. A healthy diet devoid of oil doesn't make a healthy country. So it is a prime requirement of the agriculture to produce that. Let us say an important revolution has to take place, and that is oilseed revolution. I wish there were some Professor Swaminathan was younger by another 20 years, he would have done miracles. He made the green revolution, but I think we require, it is important to make an oilseed revolution. By whatever may be the sources, don't worry about the source. Look for the quantity of the agricultural product. Once it is there, like milk, you can do wonders. Today, dairy doesn't only produce milk, it also produces many snack items, right? Curds, yogurt, everything it produces. So once you are in large amount, and India became self-sufficient in 1997, and it's 23 years, we are number one in the world. Very difficult to beat us, huh? Very difficult to beat us. And the West will also say that you are wasting milk. Come on, man. It is very difficult to satisfy everybody. Let us be happy with what we are doing. We know what to do. We have the brain power. But at the same time, we as scientists will keep open our eyes and ears for the innovative technologies, for the innovation around the world. And we would like to be a partner in everything to make sure that the ban, the mental ban that people have put on oils and fats need to be removed and made sure that that much amount of oil is also produced in India, provided the oil mills get the oil seeds. Otherwise, what do you think? How can they extract from their palm? Palm means I'm not talking palm oil from their palm. They can't extract oil. You need to give them seeds. They will give you oil. So it is important. The backward integration is the trick, which will also help in doubling the farmer's income. And I think if we make it all inclusive, along with the system, co-product, byproduct, with a lot of carbon neutrality, and at the same time, I like what Dr. Wadke said about energy. The energy per 250 kilograms or a ton of seed has to be at a much lower, but still, I think if we have the factory running at a little bit better scale, we will overcome the price structure. We'll also overcome the nutritional deficiency, which is very, very important. So therefore, my dear friends, it is important for us to remember that India has come a long way. Let us not comment or say we have not done anything. We have done much more than what many countries have been able to do in 75 years. But one thing is for sure, the best has not yet come. We are moving forward. Let us be optimistic. Let us be confident of innovation. Let us respect our industries and the scientists. And at the same time, we need to ask the farmer to grow more, provided we can absorb what he grows with a reasonable price. You can't really ask him to grow and then don't buy from him. Then it will not be possible to do this magic. And I'm sure, I'm very, very, very positive that the policies that emerges will help India by at least 2030, we are somewhat self-sufficient in the oil consumption market, both from both from internal system as well as there must always be some complementation from external, but that's fine. But I think that's where a great subject, Kaul and Jindal have selected this very important subject. The earlier subject we took was dairy. It was fantastic. A lot of myths on dairies were taken out as A1A2 milk, and India is no longer branded as A1A2 milk. Amazing. So India shines high with the tricolor. Because why? Science and technology has shown there is nothing like A1A2 milk. Who told you that? So everybody is keeping quiet. So therefore here also I would urge that this is purely science and technology with the backdrop of the backward integration of oilseeds. Let there be 10 different kinds of oil. That is India. So it is the way to go forward, and I wish you all the best. And I congratulate the industry for the marvelous job they are doing, and the scientists and technologists, and the organizations like Solvent Extractor Association and All India Food Process Association to come hand in hand and make a report which is very short but penetrating to the government, so that they also get a guidance from people like us. And how much it is going to be used, that is left to how much we can pursue that forward. But I think we should tell the right thing at the right time. And things are at the right place now, and we should really make it happen. So that by 2030, in about 3,500 days, can we look at self-sufficiency? A tall order. Don't worry. Don't worry. Fix the target better than others. Then we will win. Thank you very much for giving me this opportunity to express some of my ideas, which are both by science and by emotion. Very important. I would like to close my comment, Prabodh, with the point that Madame Curie said, with the love of research and not mere knowledge and intelligence, it doesn't make a scientist. You need to have love for research. You need to have love for research. Research is not a paying contribution today, but research is important, both in the agricultural sector as well as in the technology sector, as well as the consumer sector, as well as the health sector, the nutrition sector. It is very, very important to remove that, what you call a wrong label, that oil is bad, is not correct. It's time that we remove that brand. But too much oil is bad, agreed. But minimum oil, if you don't give it to the brain, I can't be speaking like this today. If you had fasted me for oil for the last 1 week, I would say I can't participate today. Brain won't work. It's important to realize how important is oil to the brain and to the body. So I think with that, I would say nature has made everything to the benefit of its own living matter, but man utilizes it. But then he has to have his limits also. With that, I took a little bit more time, Prabodh, and the reason I took that time is to complement and supplement what others spoke. I thought a little bit more about medical angle, nutrition angle, and the unnecessary label that oil carries. This is bad for you, please purchase. Who will purchase? Nobody will purchase. And so I'm still surprised that people are adamant to purchase. So that means people are smart, consumers are smart. They're hearing somewhere. So with that, I close down my comment and look forward for the bright discussions ahead. Thank you very much, Prabodh and Jindal and Kaul, and all the speakers compliment you for your fantastic presentation. Each one was better than the other. Thank you.
Thank you. Thank you, sir. It was mesmerizing hearing you. And let me tell you what actually you have added. I was thinking like it is a technical talk and it is not like a presidential talk, but nevertheless, scientist is always a scientist.
Thank you. Thank you.
So, Jindal Saab, any last comment you want to make before I offer a vote of thanks to both Jindal Saab, Dr. Jindal Saab? Anything you want to just add a comment? Closing line?
Thank you very much, Dr. Halde. I just want to, reflect upon a couple of points which I have tried to absorb during the, preliminary talks. The perception of oil among the consumer needs to change. Dr. Prakash mentioned it very lucidly. B, marking food product labels with oil as bad. Oil is not required. If there is certain percentage of oil in food, it is to be marked red. This concept needs immediate understanding, discussion, and review. It is by chance, or many people think there are vested pressures that our regulatory authority is bent upon this course with saying that reduce sugar, salt, and fat by mandatory legal requirement in foods. I think we need to have a webinar on that issue. And I will request Dr. Prakash to think about it and throw light on it. And our youngster team with Dr. Prabodh Halde, sort of take the lead in that and bring to discussion our experts from FSSAI, from scientific and academic institutions, from industry, and work out that what oil actually is, how much it is required in the body. If oil was not required in the body, nobody would be growing oil seeds and making it in the first place, right? And to understand the function of oil in the physiological system in the body, and how much of it and which oil. Still, I think there are gaps. So I will request all the learned speakers to maybe work on these issues, which are application-oriented issues. They are concerned with the industry and the consumer. And finally, there is technology behind them. So please, let's plan. Dr. Prakash, think of it if this topic can be taken up in serious concern. And I think we have not heard Dr. Dresker, if he wants to say something, any of his reflections and views of, participating, sparing his time and listening to all the, viewpoints. So if Dr. Halde can invite him for a brief.
Yeah. Yes. You have invited him. So I also repeat, Dr. Dresker from the USA, if we want to give some morning thoughts for you, and for us, it will be the closing thoughts.
Well, let me be very brief. First of all, thank all of you very much for the fine presentations, and I very much appreciate the invitation to join and to listen, to learn. I agree with the points made across the board. I had not been aware, frankly, that India was importing as much edible oil as apparently is the case. Clearly, India has the capability to be not only self-sufficient, but also a large exporter. And the application of technology, served through application engineering, I think is the obvious way forward. We believe that the technology that our company has developed can have a role in this goal for India. And I very much look forward to continuing the conversation, either as a group or individually with you. And again, thank you very much for allowing me to participate.
Dr. Dresker, can you send us a write-up on the technologies which you have developed and you would like the industry to know about? If you send the same to All India Food Processors Association, we can disseminate it. Okay.
Yes, let me refer you to Dr. Cowell. We have worked with him and with Marienthal for the last several years. he is in possession of a general presentation from us
Okay.
that covers not only the oilseed side of the business, but also the herbal or leafy greens side. So,
Okay. Thank you very much, Dr.
thank you.
Okay.
Please, Dr. Haldi.
Thank you. Hello. Thank you, President Sir, and thank you, our today's chief guest, Dr. V. Prakash Sir.
Thank you,
And
Namaskar.
I would like to take this opportunity on behalf of All India Food Processing Association. First, we would like to really thank our chief guest for taking time. I know how busy he is. And in spite of all his busy schedule, sir, you started in opening and also stayed back. Nowadays in the webinar, most of the people do multitasking, but you have attended, and though this quality of the seminar was amazing, but the quantity of the people we couldn't.
Hello. Hello.
I think there is some connectivity problem.
Hello. Dr. Halde.
I understand he must be in CFTRI guest house. He should come out of the guest house and then he will get the connectivity. This is a very old building with thick walls. So, so that may be the reason.
And Dr.
I will-
Halde,
I would request Dr. Jindal if you could, I think he's lost the connectivity, please.
okay. Okay, in that case, I really wish to thank all the learned speakers and all the participants. It's all a teamwork. And when any issue, a product, a service relates to a consumer in the end, industry being the bridge for that, we need the support.
Some error. No,
Yeah.
I have joined
Halde
back.
ji, yeah, please, you have come back. Yes, please.
Sorry, no, there was some kind of, I'm in the CFTRI campus, there is some problem with the network. So I was saying thanks to Dr. RBN Prasad, who has taken his time, and excellent presentation, Dr. RBN. Every time you add some value, and it is amazing to see your presentation. Dr. Vatke Sahab, we have heard you at various platforms, but at today's presentation was something different. And it was so simple in language and people understood. Except that in the oil, what expelling is not the simple thing. There are many aspects, organoleptic quality of the oil, then the waste utilization and many. So we appreciate from the bottom of heart. And to Dr. Kaul Saab, at this age, without any issue of your health, you have actually taken your initiative of arranging this kind of program, and we are really thankful to you. He's our ex-president, but your energy, your passion, and next time we will make it bigger and better. Thanks to our president Jindal Sahab, you always encourage.
I would like to speak one point here. Dr. Halde,
Yes, sir.
will you allow me, please?
Yes. Sir, all yours. Stage is
You
yours.
see, I missed one thing in my presentation about the technology that I spoke about, that this technology, number one, the color issue is totally, taken care of. Because this gaseous solvent, it has only affinity with the lipid. It removes lipid. So the degumming process, desolventizing process, and other processes are all getting eradicated. And you have no color problem at all, which I have shown the two bottles with one color and the other color. And the solid residue you have seen, the technology that we use with the solid residue, the soybean flakes were absolutely white. So that is the added advantage of this technology, which I missed because I had to run through
Appreciate.
under the pressure of strain of time. That is what I wanted to say. So this use of enzymes, use of process, degumming, desolventizing, and to the greater extent, these things are taken care of. So that is the beauty of the technology that is under development and almost developed for industrial application.
Thank you.
Yeah. Please
Can
continue.
No, let me complete the formal vote of thanks and then we can actually have one or two points, if anything. So let me complete the vote of thanks, Dr. Kaul Sab. So then next, definitely anybody wants to add value, we will. So thanks to Kaul Sab for initiating and bringing so galaxy of the speakers on this program. Thank you to you, sir. Thanks to Jindal Sab for encouraging us and motivating us for bringing different aspects and different. Last time we did on dairy, this time is on the oil. We are planning for nutraceutical, we are planning for the nutrition, and we will try, Jindal Sab, every 2 months we will organize some kind of good discussion webinar. Last but not least, all our participants, still on the Friday evening, more than 30 odd participants are there, and thanks to all participants for adding value by being present and also asking the right questions. Would like to also thanks to all the organizing committee and my office bearers of AIFPA for supporting and making this event so successful. Thank you. Have a great weekend. Take care of yourself because COVID has not gone. The number of cases are increasing. Mumbai is increasing. Delhi might get increased. So we need to take care of our health, and health is real wealth. Thank you and God bless. Jai Hind. I declare the program is over, but yeah.
Can we have some questions now?
Dr. Halde,
Sir.
I just want to make a request to Dr. Prasad and Dr. Watke.
Sir.
You see, all the deep knowledge that they possess, we need to pick up some of it to present it to the industry, circulate it. Some salient features of how things should be done, and also for the consumer bodies and other stakeholders concerned. I will request both of them if they can write one paper each for the association journal, which we call Indian Food Packer, which is circulated to the entire industry, research organizations, academia, government, embassies, high commissions, exporters, almost everyone who relates to the field. Let's take up this concept, of the future planning for sustenance, for utilization, selection of the product to a greater, width. So
may I?
Yeah,
Dr.
please.
Prabodh, may I?
Yeah, please.
Yes, suggestion will taken. I have already forwarded my PPT to Vikas. Your suggestion of writing a paper, yes, we can do that. Dr. Halde mentioned at the beginning that I have written a book on this subject, Principles of Vegetable Oil Extraction. It's a comprehensive book covering both mechanical expression as also solvent extraction. It's about 500-page book and will soon be published. Thank you very much.
Thanks.
I'll provide you, sir.
Thank you. And
Thank you.
Dr. Halde, will you kindly coordinate with
I will.
both the experts and have the papers prepared? Okay. Thank you.
Actually, Dr. Jindal, what I have seen, this COVID has helped us, the association, different associations working in the different sphere, but I think we are getting touched with each other and there is a common program which is finally Make in India, Support India, Consumer Safety and Atmanirbhar Bharat. I think it is a high time that we should connect cross other association and getting it work together for the common minimal program, which is our agenda of the India. And I will both the speakers, both the experts, and fortunately they are part of our other association. And Dr. Jindal will also write a synopsis of today's presentation, which is a really great. So we'll work with the Dr. Kaul, and we will publish actually a small report on this with their technical input.
Okay. Thank you very much.
So I declare that today's anybody was
I think Mr.
mentioning
Bansal
something,
wanted
so
to say
I missed
something.
that.
Mr. Bansal,
Yes, sir.
He was asking
you
to
wanted
speak.
to say
So
something
with permission of
Yeah,
Dr. Jindal, we may
Yes,
allow.
sir.
in
Yes, sir.
brief? Yeah.
Yes, sir. It was a very, very informative session. And, Dr. Kaul, you have to take it forward. And if Dr. Prakash is around, I just wanted to, say something to him that he's looking so young even today. I wanted to find out that which vegetable oil he's using at home.
Oh, I don't have any secret about it. Whatever oil you give me, I take it in moderation, but I burn it also. It does not matter. But I have some minimum amount of oil. And as long as you can burn it, then fine. If you cannot burn it, take less. That's all. And
So that's the mantra.
Thank you. Thank you.
Okay. Okay. All the best.
So if there is any
Namaskar.
feedback, you can please
Thank
send
you,
it to
Dr. Dreesker.
at the email.
Have a nice
address.
weekend.
Thank you.
I wish a nice weekend. to Dr.
Thank you,
Dreesker.
Gulsab.
Thank you.
With
Thank
your
you.
good wishes.
Thank you, everyone.
Yeah.
Thank you very much.
Thank you. Thank you.
Bye-bye.